Binomial probability distribution. In this video, we're going to find out how to calculate probabilities in a binomial probability distribution. Binomial means there are two possible outcomes. Instead of just going right to a formula, we're going to do an example and see if we can come up with a formula on our own using ideas and techniques that we have already learned in probability. So our example, in the United States, 6.8% of the people have O negative blood. A random sample of size 4 is obtained. Construct a probability distribution for this experiment. What is a probability distribution of size 4? Well, it's the following. We want to find the probability that 0 people out of 4 have O negative blood, that 1 out of 4 has it, the probability of 2 and 3 and 4 people out of 4 have O negative blood. And we're going to find all of these different probabilities. These are the only possibilities that we could determine out of 4 people. When we add the total probability at the end, it should equal 1 or be very close to 1 depending on a rounding error. So how would we find the probability that none of the people out of 4 has O negative blood? Well, the probability that the first person does not have it is 1 minus 0.068, or 0.932. And the probability that the second person does not have it is the same, 93.2%, and the third and the fourth. So we go right to the answer here, just using our exponents, and saying that the probability that nobody out of 4 has O negative blood is about 0.755, or 75.5%. Now, I left a little space on purpose. We'll come back in just a bit. What is the probability that 1 person out of 4 has O negative blood? Well, let's assume that the first person has O negative blood. So there's 6.8% chance that person has O negative blood. And then the next 3 people would not have O negative blood, and we would get 0.068 times 0.932 cubed. But my question, is that all the different ways that we can choose 1 person out of 4? Well, of course not. It could be the first person only, or the second person only, or the third person only, or the fourth person only. So there are 4 different ways we could choose this. So I could multiply this number that I just found by 4, but we understand combinations. Or if you don't know combinations yet, go back and watch that video. And we know that we can find the number of ways we can choose 1 out of 4 by doing 4C1, which happens to be 4. And then when we get this value, we find that the probability that there is 1 person out of 4 having O negative blood is about 22%. How about 2 out of 4? Again, let's assume that the first person and the second person have O negative blood, meaning that the other 2 people do not have it. But is this the only way we can choose 2 out of 4? Is the first 2 the only way? No, of course not. Well, how many different ways can we choose 2 out of 4? Well, that is 4 combination 2, which happens to equal 6. And then if we multiply all of these numbers together, using our calculator, of course, we get a value of 0.024. About a 2.4% chance that 2 people will have O negative blood. I think you see the pattern, but we'll keep going. What's the probability that 3 people will have O negative blood? Let's assume it's the first 3, so 0.068 cubed. And then the 4th person does not, so times 0.932. Now, how many different ways can we choose 3 people out of 4? Because the way I set it up is implying the first 3 have it, the last one does not, but there are other ways that we can have 3 out of 4. And of course, we need to multiply everything by 4 combination 3. And then we get a value of 0.001. What is the probability of 4 people having O negative? Well, it's 0.068 to the 4th. Now you could say, how many different ways can we choose 4 out of 4 where there's only 1? Just like how many ways can we choose 0 out of 4? There's only 1. But just to make our pattern complete, we could put those things in because 4 choose 4 and 4 choose 0 both give us 1. And then we get a value of 0.00002. So if I were to add all these things up together, I would get a value that should be pretty close to 1. And I'll go in and do it just to confirm that we get something pretty close to 1. And we do. I have a rounding error here because I rounded up a couple times, and I get a value of 1.002, but that was simply based on rounding. Very close to 1 when we add all the probabilities together. So hopefully you understood what we did using ideas we've used before. I'm now going to show you the formula, which is the following. And if I had just given the formula to you, you might think that's pretty confusing. But I want you to think back and notice this is exactly what we did above. And or you don't even need to use this formula if you understand what we did before, above here. Let's take a look at another example with a few parts. So in 2026, the year of the World Cup in Canada, the US, and Mexico, 42% of the households in the United States watched a World Cup game. A random sample of 20 households was taken. What is the probability that exactly 9 watched a World Cup game? Well, we can assume that the first 9 watched a World Cup game, so the probability of the first household was 0.42 and the second household was 0.42, and so the first 9, since we're multiplying probabilities with multiple choices, we get 0.42 to the 9th. And then we could assume that the next 11 did not watch a game. Well, what percent of households did not watch a game? Well, it's 58% of each household. That's the probability did not watch a game. Now, once again, we're assuming that the first 9 watched a game. That is, the first 9 households we contacted watched a game, and the next 11 we contacted did not. But is that the only way we could have 9 out of 20 watch a game? Of course not. And we could do that by using a combination. 20 choose 9. So if we plug all of this into our calculator, and of course I am using the calculator formulas to help me do a lot of this here. That is, I'm using my combination formulas and typing it in. And we get a value of 0.1707. So about a 17% probability that exactly 9 out of the 20 households watched a World Cup game? What is the probability that fewer than 2 watched a game? So we're really trying to find out the probability that either 0 or 1 watched a game. So let's set it up. What's the probability that none of the households watched a game? Well, it's 20 choose 0, right? Times 0.42 to the 0, because none of them watched. And there's a 42% chance that somebody watched. And then we had the 58% chance that they didn't watch, and we're assuming that all of those did not watch. Plus, now what's the probability that 1 out of the 20 watched? Was 20 choose 1, or 20 combination 1. And then 0.42, 1 watched, and 19 did not watch. And so if we type all of this in, we get the following value. We get a very, very, very small number. And I'll put it right about here. Is 0.000287. So way less than a 1% chance that fewer than 2 households watched a game. So what's the probability that at least 2 or more watched a game? Well, of course, that's a probability that 2 or 3 or 4 or all the way out to 20 watched a game. That's a lot of work, right? Probably 2, 3, 4 out to 20. What is the shortcut to doing this? Well, notice that this is the complement to the number that we just found. So instead of doing a lot of work, we can simply do 1 minus the value we found in part B. And we get a probability that at least 2 households watch a game of 99.97%.